In this activity, you don't need to graph. You are just looking at the equations and thinking, are these going to have no solution, one solution, infinitely many solutions? And what you're going to observe is you're first going to observe the slopes. In this case, they have the same slope. So that means either they're the same line or they're parallel lines, right? And we know they're the same line if they also have the same y-intercept. And if they have a different y-intercept like this, these are parallel. So these are lines that are going to run parallel to each other, like this, and they're never going to meet, right? What do we observe? When they're both in slope-intercept form, they'll have the same slope and different y-intercept. That means they're going to run parallel to each other, and they have no solution because they never meet. Okay, let's look at another one. Here, the same situation is true. They have the same slope. They have different y-intercepts. They will run parallel and have no solution. Okay, again, the same slope, different y-intercept, right? Tricky here because the y-intercepts look similar, but this is a 7, this is a 3. This is, again, no solution. I'm trying to find one that's something different. Okay, now look. See, this is a slope of 10. This is a slope of 7/8. Those are different slopes. So these lines are not going to be parallel because they don't have the same slope, and they're not going to be the same line because we can see that they're different. So these are going to be two lines that have different slopes. They're going to look like this. They're going to meet at some point on the graph, and they're going to have one solution at that point where they meet. Okay, now here, this is an example of two lines that are actually exactly the same line. They have the same slope, they have the same y-intercept. These lines are going to sit on top of each other and have infinitely many solutions. Okay, and what's going to happen is when you get to these higher numbers, you're going to get equations in standard form. Okay, now what can you do with standard form? You can observe these in a couple ways. The first thing you can do is you can decide, I'm going to just rearrange this into slope-intercept form and this into slope-intercept form, right? So I would subtract 3x from both sides, divide by 4. You could do that and see, what do they come out as? Do they come out as the same, right? The same equation? Do they come out as equations with the same slope and different y-intercepts? Okay, you can also observe, I can observe these equations just directly in standard form. And what I notice is that if I were to take this equation and multiply it by 5, right? And the reason I chose 5 is because 3 times 5 is 15x. If I were to multiply this equation by 5, I would get 15x. 5 times 4 is 20y. And then 5 times -8 is -40. So I notice this is pretty similar to this bottom equation, but it's not the same as the bottom of equation. So if I were to change these into slope-intercept form, I would subtract 15x from both sides, divide by 20y in both cases, and I would end up with the same slope. However, I would end up with a different y-intercept. Because when I do -40 divided by 20, I'm going to get something different than if I do 6 divided by 20. That's where my y-intercept comes from. So these lines are examples of lines that if I were to rearrange them into slope-intercept form, they would have a different slope, the same slope, but a different y-intercept. That means they are parallel lines that will have no solution. Okay? And remember, you can always access the tutorial and learn from the example on IXL.